Welcome to Xamarin University and Android 241, Gestures in Android. Over the past several years, touch on mobile devices has become our primary means of interacting with our mobile applications. This is definitely true for Android smartphones and tablets. When was the last time you saw a consumer Android device that included a keyboard? Well, with this reliance, or this requirement to use touch, we've seen some common interaction patterns emerge, sometimes using multiple fingers at the same time. I'm sure that you have swiped, pinched, or rotated your fingers on the screen and expected a result. Well, these more complex patterns are called gestures, and today we're going to learn how to use and create gestures on Android. We'll start by exploring the gestures that are provided with the Android APIs. And to do this, we'll talk briefly about what a gesture is, what gesture support is available out of the box for us as Xamarin Android developers, and then we'll see how to add and respond to gestures in our applications. A touch gesture, at its simplest, simply requires a user to touch the screen. Now, more generally, we define a gesture as a recognizable, repeatable, continuous series of touch interactions. For example, a swipe or a fling gesture from a high level is composed of 3 steps. The user touches the screen, the user moves their finger in roughly a straight line, and then the user lifts their finger. And once the user completes all 3 steps, the application would recognize the movements as a swipe or a fling. In Android, a gesture can be as simple as touching the screen. That's called the on-down gesture. If a tap is held for approximately 100 milliseconds, on-show press occurs. If a tap is held for approximately 600 milliseconds, on-long press occurs. The on-fling gesture occurs when a finger touches the screen, moves, and then releases. On-scroll is raised anytime a finger is moved while in contact with the screen. It's not mutually exclusive with the other gestures either, so you can receive both an on-fling and an on-scroll for the same interaction. And we also have the on-single tap up. So this occurs if a finger touches and releases the screen in less than 600 milliseconds with no significant movement. And the Android APIs expose other common gestures as well, things like the on-double tap and the on-scale. However, there's other gestures that are not built in. If we try to think of a common gesture that we haven't talked about yet, well, something like rotation would be a gesture that's not included in the Android APIs. Android uses objects called GestureDetectors to recognize these gestures. More specifically, they interpret a continuous series of motion events and watch for specific gesture patterns. When the user interacts with the screen, views and activities receive motion events, describing each discrete phase of that interaction. We can pass those motion events into a gesture recognizer, and it can notify us when a gesture is performed. Android includes 2 default gesture recognizers. The GestureDetector is used to recognize the most standard gestures, things like tap, double tap, swipe, and flick. There's also a second gesture detector called the Scale Gesture Detector that's used exclusively for scale gestures, also commonly known as pinch and zoom. When responding to gestures, it's most common to use the listener interface pattern. There are 2 listener interfaces for the standard gesture detector. The IonGestureListener is used for single tap, swipe, flick, and long press. For double tap gestures, use the IonDoubleTap gesture listener. When working with the scale gesture detector, a third interface, IonScaleGestureListener, is used. Now, depending on which gesture you want to recognize, you'll select a different interface. These interfaces are not mutually exclusive. You can use 2 or all 3 at the same time, and even implement them on the same class. Let's take a look at each one in turn. The IonGestureListener defines 6 methods representing 6 different actions you can take. On down is called when a finger touches the screen and no other fingers are already in contact. On show press is called when a finger has been in contact with the screen for approximately 100 milliseconds and hasn't moved or lifted. This is primarily used for UI purposes. So for example, maybe to show a highlight when a specific view is being tapped. On long press is called when a finger has been in contact with the screen for approximately 600 milliseconds and hasn't moved or lifted. And that's often used to show context menus or to access less commonly used features. On single tap up is called when a finger has touched the screen, hasn't moved, and then releases in less than 600 milliseconds. So what this means is you'll get a on single tap up or an on long press for a given interaction, but never both. However, it is possible and actually likely that on show press will be called regardless for both of those interaction patterns. And then our second interface is the eye on double tap gesture listener. That's used with the GestureDetector object, and it defines three methods. On double tap is raised for a double tap gesture. Remember, this means that a finger touches the screen, lifts, and then touches the screen again. The finger doesn't need to lift the second time for this gesture to occur. On double tap event is raised for each step of the double tap gesture. And the on single tap confirmed is an alternative method for detecting single taps, and it duplicates the functionality of the on single tap from the previous interface. Then there's a third listener interface called the eye on scale gesture listener, and this is used with a scale gesture detector to respond to pinch and zoom style scaling gestures. Now that we've explored the pieces, let's put that all together. First, we'll implement one of the interfaces. It's common to do so on an activity or a custom view, but like the other listener classes, this isn't a requirement. So here we're going to implement it directly on our activity. The eye on gesture listener interface requires us to create these 6 methods for each of its supported gestures. However, it's not necessary to respond to each method. For the unused gestures, simply leave the method blank or return false depending on the return. We'll also need to instantiate a GestureDetector. As you can see on this slide, this is often done in the onCreate lifecycle method, but again, this is not a hard requirement. When creating a GestureDetector, it takes 2 arguments. The first is the active context, and the second is a class that's implemented the appropriate interface. In our example, we're assuming that the activity has implemented the eye on gesture listener, as we saw in the previous slide. And then there's one more step before the GestureDetector is able to do its job. The motion event objects generated from touch interactions must be passed on to the GestureDetector, and that doesn't happen automatically. So here's an example. We simply call the GestureDetector's onTouchEvent method, and we'll pass in the motion event. You can continue to use the motion event for other purposes as well. You can respond directly to the motion event actions, or you can even pass it on to a second GestureDetector. And now you're going to work on the first individual exercise. Open up the worksheet that you downloaded from the Xamarin University website that goes along with this lab. Open exercise 1 and get started. When you're done with that exercise, come back to this video and continue. Now that we've seen how to respond to gestures using the eye on gesture listener interface, let's take a look at responding to double taps. This requires us to implement the eye on double tap listener, which defines 3 methods. On double tap is called when a double tap occurs, and this is the method that we're primarily interested in when responding to double taps. And as discussed earlier, the on double tap event is called when an event within a double tap gesture occurs, or more specifically, each time a finger presses or leaves the screen. And then the on single tap confirmed is called when a single tap occurs. To respond to double taps, we pass in an object that instantiates the eye on double tap listener to the GestureDetector using the setOnDoubleTapListener method. Notice that this is a change from the eye on gesture listener, which is passed in through the constructor. Notice you still need to pass in an object that instantiates the eye on gesture listener, and that means that to use eye on double tap listener, both interfaces will be implemented. Let's now take a look at our other gesture detector, the scale gesture detector. The steps to using this gesture detector are similar to what we've seen already. First, implement the associated listener, eye on scale listener. Then create an instance of the scale gesture detector, passing in the listener object. And again, we'll need to forward the motion events to the scale gesture detector object. And here's an example. Again, we're implementing the interface on the activity and instantiating a scale gesture detector, passing in a reference to the listener, which is our activity. The eye on scale gesture listener requires 3 methods. On scale, this is raised as the gesture is being performed and can be used to track changes. OnScaleBegin is called when the gesture is first started, meaning 2 fingers are on the screen and they're moving. OnScaleEnd is called when one of the fingers has left the screen and the gesture is no longer being performed. And again, we need to forward the motion event to the scale gesture detector. Pass them in using the onTouchEvent method. And now go back to your second individual exercise and we're going to implement the scaling gesture. Again, pause this video and come back when you're done. So we've covered a lot of ground so far. We learned how to use 2 gesture detectors and 3 listener interfaces, enabling us to add support for Android's built-in gestures into our own applications. And now that we've seen how to use the built-in gestures, let's build a custom gesture. To create a custom gesture programmatically, we'll need to create both the detector object and the interface to define the listener. A custom gesture simply refers to a gesture that isn't already included in the APIs. It could be a common gesture that isn't provided. So as we discussed earlier, currently the APIs do not provide a rotation gesture detector. Or it could be something completely unique to your application, a custom gesture to perform a game action, for example. We can categorize gestures by how they're performed. Continuous gestures don't have a fixed endpoint. Think about rotation, translation, or scaling. These gestures are continuous. As long as the user is in contact with the screen and moving the appropriate number of fingers, these gestures can be performed indefinitely. In contrast, discrete gestures have a fixed path. When that path has been followed, the gesture is considered complete. And if the path is deviated beyond a specific threshold, the gesture will need to be restarted. Now, as I mentioned earlier, we have 2 things we need to create for our custom gesture. We'll create a class that's able to interpret touch events and recognize our gesture. And we'll create an interface to define a listener. Or more specifically, the interface will define the method or the methods that will be called as the gesture is performed. So in this section, we're going to explore creating custom gestures programmatically. And we can create both types of gestures this way, discrete or continuous. Later on, we'll talk about another technique for creating custom gestures, but that's limited to discrete gestures only. So we'll start by defining a listener interface for our custom gesture. This interface can define any methods you think might be useful for consuming the gesture. For example, with discrete gestures, you could have methods that notify the client when it started, completed, or failed. For continuous gestures, you'll likely want a method that can be raised during the gesture. In our rotation example, we can pass the angle as it's performed. And you're the architect. You can include specific details like point locations or even pass the motion events. The custom gesture detector class doesn't have any hard requirements, but for simplicity and ease of use, it's a good idea to follow the patterns that are set by the existing gesture detectors. First, notice the class doesn't derive from a base class or implement an interface. It's just a class. In the constructor, we'll accept the listener that we just defined as a parameter and then save it off. It will be used to notify the consuming client of the gesture. Now, because this is just a class, you'll need to provide some way for the class to receive motion events. Let's follow the patterns laid out by the API and create a public method named onTouchEvent that accepts a motion event. Using the motion event and the skills that you would have learned in our AND240 class where we introduced touch in Android, you'll add the specific logic for your custom gesture. So now it's time to think about the specific events that are required for the gesture. Rotation is a continuous gesture and it requires 2 fingers to be in contact with the screen. And then the relative motion of the fingers will determine the rotation. We also need to think about when the gesture is over. So in this case, when the fingers leave the screen. So we will listen for the finger 1 down. Nothing happens. And then with the finger 2 down, our rotation begins. When we start moving the fingers, that's when our rotation will start and we'll get the angle. We'll lift a finger up, the rotate will end, and then when we lift both fingers up, nothing else happens. To code this behavior, we'll use the motion event actions provided by the motion event objects that are passed into our gesture detector's onTouchEvent method. This is where the specific logic for your gesture will be added. And this might be a significant amount of work depending on the complexity of your gesture. And again, remember the client or the user of the custom gesture detector needs to call the detector's onTouchEvent method, passing in the motion events. In exercise 3, you're going to go build a rotation gesture. As I mentioned earlier, there is an alternative if you're building discrete gestures. The Gestures Builder application can be found on most Android devices, and the icon is typically a pink swirl on a notepad. The app is also available on Android emulators. To create a discrete gesture using the Gestures Builder is straightforward. Open the application, press the Add Gestures button, add a name, and start drawing your gestures. Using the gestures created by the Builder application requires several steps, including exporting the binary that contains the gesture, adding that binary to your application, and using specific APIs to detect and score the gestures. Now, if you'd like more details on using discrete gestures created in the Gestures Builder application, check out Xamarin University's Lightning Lecture section on our website. In this section, we learned how to create custom gestures programmatically. And we also created a gesture that's commonly used, but is currently absent from the provided Android APIs. You can take and extend that custom gesture to use in your own applications. Thank you for watching this video on Android gestures with Xamarin University.